of the Mathematics 1. Today our topic is System of Non-Homogeneous Linear Equation. Now, first of all, what is a system of non-homogeneous linear equation? A system of m non-homogeneous linear equation in an unknown variable is represented by a11 x1 a12 x2 plus a1 xn equal to b1, a21 x1 a22 x2 plus a2n xn equal to b2, so on am1 x1 am2 x2 amm xn equal to bm. In matrix form ax equal to b, that means we write as a11 a12 a1n a21 a22 a2n am1 am2 amn, and it is x1 x2 xn, and it is b1 b2 bn as per this formation. Okay, so now solution of system linear equation. For a system of m linear equation in an unknown, there are three possibilities of the solution to the system. The system has unique solution, the system has infinite solution, and the system has no solution. There is three options to get the solution. First, system has unique, that means only one solution. Infinite solution, that means too many solutions. And no solution, that means there is no exists any solutions. Now, when the system of linear equation has one or more solution, then the system is said to be consist, otherwise it is inconsist. So, the linear system has unique solution, that means determinant A does not equal to 0. A matrix A gem B, that means A11, A12, A1n, B1, A21, A22, A2n, B2, AM1, AM2, AMn, Bm is called augment matrix of the given system of non-homogeneous linear equation. To solve a system linear equation, elementary transform are used to reduce the matrix either row echelon form or reduce row echelon form. Now, Gaussian elimination method to solve this. First, reduce the matrix to row echelon form is called Gaussian elimination method. The Gaussian elimination method for solving the linear system is as follow. First, write the matrix. Obtain the row echelon form of the matrix by using elementary row operation. Write the corresponding linear system of the equation from row echelon form. Solve the corresponding linear system of equation by the back substitutions. Now, Gauss-Jordan elimination method. Reducing matrix reduce row echelon form is called Gauss-Jordan elimination method. The Gauss-Jordan elimination method to solving the linear system is as follow. First, write the matrix. Obtain the reduced row echelon form of the matrix by the elementary row operation. For each non-zero row of matrix, solve the corresponding system of the equation and unknown associate with the leading one. It is Gauss elimination or Gauss-Jordan method. Now here, Gauss elimination method is followed to row echelon form and Gauss-Jordan method is followed to reduce row echelon form. Now taking example, solve this example using Gauss elimination method. System is x plus y plus 2z equal to 9, 2x plus 4y minus 3z equal to 1, 3x plus 6y minus 5z equal to 0. We are converting as a matrix form. Ax equal to b, so we get 1, 1, 2. The coefficient of x is 1, y is 1, z is 2 and b is 9. So 1, 1, 2, 9, 2, 4, 3 minus 3, 1, 3, 6 minus 5, 0. This is our matrix. Now, convert into A gem B form. 1, 1, 2, 9, 2, 4 minus 3, 1, 3, 6 minus 5, 0. Reducing this matrix to the row echelon form, What we do in a row echelon form? We are 0 in replace to 2 and in replace to 3. So R2 minus 2R1 and R3 minus 3R1, we get 1129, 02 minus 7, minus 17, 03 minus 11 minus 27. So now as per the row echelon form, we are converting R2 as a leading 1. So we divide 1 by 2 R2. 1129, 01 minus 7 by 2, minus 17 by 2, 3 minus 11 minus 27. Now as per the property of row echelon form, we are converting 3, R3, a middle value 3 in 0 formation. So we are taking R3 minus 3R2. So we get 1129, 01 minus 7 by 2, minus 17 by 2, 00 minus 1 by 2, minus 3 by 2. As per the row echelon form, we are taking a leading one in row 3. So we are multiplying with minus 2 in R3. So we get 1129, 01 minus 7 by 2, minus 17 by 2, 00, 1, 3. It is our row echelon form. Now what is our system? X plus y plus 2z equal to 9. Y minus 7 by 2 z equal to minus 7 by 2 and z equal to 3. It is our equation number 1, 2 and 3. Now to solve this system, we are taking z equal to 3 in equation number 2. So we get y minus 7 by 2 into 3 equal to minus 17 by 2. So y equal to minus 21 by 2 equal to minus 17 by 2. So we get y equal to 2. Now put value z and y in x. That means equation 1, we get x plus 2 into 3 equal to 9. So x equal to 1. X equal to 1, y equal to 2, z equal to 3 is a solution of the given system. Now solve the following using Gauss-Jordan method. In that case, see, in Gauss elimination we are converting matrix into row echelon form. Now it is our Gauss-Jordan method. So we are converting this system in reduced row echelon form. First of all, we are converting in matrix formation. So 1, 1, 2, 2, 4 minus 3, 3, 6 minus 5, x, y, z and 9, 1, 0 as our entries. Now converting as a HMV form, 1, 1, 2, 9, 2, 4 minus 3, 1, 3, 6 minus 5, 0. Reducing this matrix reduced to row echelon form. So we are converting 2 and 3 in 0 as per the R2 and R3. So we get 1, 1, 2, 9, 0, 2 minus 7, minus 17, 0, 3 minus 11, minus 27. Now 1 by 2 R2 due to reduced row echelon form, in row 2 we have to convert leading 1 as a first entry. So we get 1, 1, 2, 9, 0, 1 minus 7 by 2, minus 17 by 2, 0, 3 minus 11 minus 27. Now as per the row echelon or reduced row echelon form, we have to convert R3 as a middle entry 3 in 0 due to property of row echelon form. So R3 minus 3R2, we get 1, 1, 2, 9, 0, 1 minus 17 by 2, minus 17 by 2, 0, 0 minus 1 by 2, minus 3 by 2. Now convert into leading 1 into R3, we get 1, 1, 2, 9, 0, 1 minus 7 by 2, minus 17 by 2 and 0, 0, 1 and 3. Now as per the reduced row echelon form, we are converting 2 and minus 7 by 2 and 3 as a 0. So using R1 minus 2 R3 and R2 plus 7 by 2 R3, we get 1, 1, 0, 3, 0, 1, 0, 2 and 0, 0, 1, 3. Now in row 1 as a middle entry, we have to convert 0 due to reduced row echelon property. We get 1, 0, 0, 1, 1, 1, 0, 0, 0, 1. So our solution is x equal to 1, y equal to 2 and z equal to 3. Solve the following by the Gauss elimination method. The matrix is 3, 1 minus 3, 2 minus 3, 7, 2, 19 minus 47, x, y, z and 13, 5, 32 is our B1, B2, B3. Converting into matrix formations. So 3, 1 minus 3, 13, 2 minus 3, 7, 5, 2, 19 minus 47, 32. Reducing this matrix is a row echelon form. So we get 1 by 3 R1. So 1, 2, 2, 1 by 3 minus 1, 13 by 3 minus 3, 7, 5, 19 minus 47, 32. R2 minus 2 R1 and R3 minus 2 R1 we get in this form. Minus 3 by 11 R2 due to leading 1 into row 2. So we get 1, 1 by 3 minus 1, 13 by 3, 0, 1 minus 27 by 11, gem 1, 0, 55 by 3 minus 45, gem 70 by 3. Now we have to convert 55 by 3 in 0. So we have used R3 minus 55 by 3 R2. We get 1, 1 by 3 minus 1, 13 by 3, 0, 1 minus 27 by 11, gem 1, 0, 0, 0, 5. See, in this case, we have x, y, z entry is 0. So this is our system is inconsistent. So system has no solution. Important questions to do yourself and using Gauss elimination and Gauss Jordan method.